Good afternoon. I hope you're all watching and you're ready for your paper 2. I hear that there was quite a variety of reactions to paper 1. As usual, there are people who love it, people who didn't really like it, and people who are just happy with how it was. So hopefully you had a good experience, and remember, this is our Learn Extra exam revision. My name is Lee, and it's good to be with you. And remember, today, of course, our focus is paper 2, because tomorrow is paper 2 for the national examination. Right, you can get us on 0861 058 262 or on Facebook, www.facebook.com/Learn Extra. And remember, it's not EX, it's just XTRA. So please get hold of us. We love to hear from you. We love to have someone on the live with us, and we can help you through your problems. I've got some questions that have come through to us already on Facebook, and so we're going to start with those while we wait for you to come forward with your questions. So let's start with, first of all, some trigonometry. Remember that in this paper, we've got 3 major sections. You have your trigonometry, and then, of course, which is the bulk of the marks. You have your analytical geometry, which I always think is a wonderful section to score good results in. And, of course, your statistics, which is also equally, well, relatively easy to score good marks in if you know the procedures or the ways to go on it. But certainly for me, the one that seems to cause the most heartache, and from Facebook, we've heard people say, please do lots of trig. Well, we're going to start with some of the trig questions that came through. Right, let's look at the first question I have on the screen. It's from the November 2010, paper 2, question 9. And it talks about, given that tan alpha equals 3/4, where alpha is 0 to 90 degrees, with the use of a sketch and without the use of a calculator, calculate the following. Now, never mind about that. Let's just start with the essence of the question. First of all, they say, with the use of a sketch. Now, as soon as you see that, it has to be a Pythagoras type question. And without the use of a calculator, that usually means one of 2 things. Either Pythagoras or special angles. Now, how do we know it's not special angles? Well, this use of a sketch tells us that, or we look at the actual values. We've got 3/4. If it was special angles, you would have a √3, you would have a 2, or you'd have a 1 involved. And that would tell you it was special angles. Now, you haven't got a √3 and you've got a 4. If there had been a square there, yes, it could have been the special angle root, because then you would have square rooted both sides to start. So definitely for this question, it's not that, but I think this is what gives it away. So please remember, that's what you look out for when you look at these questions. Okay, so let's have a look what we do first. The first thing we know is they're telling me that tan alpha is 3/4. Where alpha is 0 to 90. So they've actually made it quite easy, really, because 0 to 90, what do we know about that in terms of quadrants? Well, there's your 0 degrees, here's your 90 degrees, so they're telling me I'm in this first quadrant, which is wonderful, because in the first quadrant, all my ratios are positive. I personally would have probably said greater than 90 degrees to force you to work in the third quadrant. Because over here, do you agree with me that tan is positive? But if we worked over here, the x value would be negative and the y value would be negative. So with tan, it's y over x, and it would be a negative over a negative, which would make a positive. So I think they've made it a little bit easier by making it in the first quadrant, but it doesn't matter. We are just looking at it. Let's get ourselves an axis going. We know we only need the first quadrant because of what they told us. And we know that this angle is going to be somewhere in this quadrant. Excuse my drawing, I should have actually had it a little lower, so let's just pick it up and move it down. Yes, there you go. Right, so what do we know? We know that this is going to be our angle alpha. Now, I am always tempted to almost put a circle in there. But I know that lots of teachers just drop their perpendicular, and then they say that is my y value, this is my x value, and this is my r value. But it makes more sense when the circle's there, because the circle sort of puts the perspective as to why we're using our r, or our radius of the circle. Right, so let's go back to the formula. We know that this is the y over the x. So the y is 3 and the x is 4. And if we know our Pythagorean triples, we would know there's a nice one that goes 3, 4, 5. But of course, we don't always know these. Sometimes they're not as easy as this. Of course, there's also 6, 8, and 10. And the other favorite is 5, 12, and 13. So if you've got 5 and 13, the missing side is 12, assuming that we're not looking for a hypotenuse. And if we've got 6 and 8, the missing hypotenuse would be 10. So these are sometimes worth knowing. They're called Pythag triples. There are many others, but these are the ones that sort of seem to happen mostly. Oh dear, I think I've just gone over the side. Anyhow, so what are we going to do? We're going to start off first of all by finding our missing bits. So we know that x squared plus y squared is r squared is the equation of a circle, or if you like, can be contributed to Pythagoras' theorem. Therefore, the x value was 4, so 4 squared plus 3 squared is r squared. So that's 16 plus 9 is r squared. And so therefore r squared is 25. Now, of course, a radius is a length, and a length can never be negative. So if the radius squared is 25, the radius must be 5. So we would happily say radius equals 5. I'm just going to draw it down here since we seem to have centered down here. It's just easier to work here. So the y value was 3, the x value is 4, and the r value is 5. That is your alpha. Right, now we go to what they want me to evaluate. And the first one is easy. It's just the sine of alpha. So if I'm looking for the sine of alpha, by definition, sine alpha can be found by finding the y value over the r value. Now, I'm sure you've been taught many rhymes in your time to remember this, so I'm not going to waste your time going through them. I will show you the kind of little grid idea I use to remember it. I go along like this and I'll say, shield your rear, cause x-rays tan your exterior. And I think we've all heard those for so many years. And so that's what we would get. So we would know that if we're reading sine, we would read y over r. If we're reading cos, it's x over r. And if we read tan, it's y over x. But I'm sure by now you've got your own way of remembering that. So the sine of alpha is the y value, which is 3, over the r value, which is 5. So that's a nice, straightforward, easy question to do. No problem as such. Right, let's go to the next one. And the next one asks me to find cos squared. I think I must just bring it up a little bit here, 9.2. It's cos squared 90 minus alpha minus 1. Now, when you get a question like this, it's never a good idea to leave this angle, because your drawing has been drawn to show the angle alpha. So the first thing we have to do is we have to use our reduction formula to change the 90 minus alpha into a more suitable ratio, in other words an alpha, so we can use the drawing. Let's recap quickly for you. Again, I'm sure this is all old stuff for you. In this quadrant, angles are just known as theta. Here they are 180 minus theta. Here they are 180 plus theta. And over here they are 360 minus theta. Now over here we know that all are positive. Sine only, tan only, and cos only. There are positive, that is. Others exist, but they're not positive. Now, none of these are 90 minus alpha. So when do we do? As soon as we go across here and we start working with the y-axis, which you agree with me is the 90 degree, here we'll be talking about 90 minus theta and 90 plus theta. We now go into what we call the co-ratios. And fortunately for you, the syllabus has been shortened a bit. And so we only have to remember that sine interchanges to cosine. Or in simple terms, sine to cos and cos to sine. Right, so if we go over here, we have cos 90 minus alpha. So it's going to change to sine squared alpha. 90 minus alpha was in the first quadrant, and we know in that quadrant all the ratios are positive. If it had been the 90 plus, something else would have happened, minus 1. Okay, so that's easy enough. Now we know what sine alpha is. We've already worked it out. It's 3/5 squared minus 1. Now 3/5 squared is 9/25 minus 1. And of course we can put that all over 25, and we were going to go 9. Remember, that's 1 over 1. 9 minus 25, which is going to give me minus 16 over 25. Okay, lovely, straightforward. It's been quite nice because what we've had to do is work out a little bit around our co-ratios, but basically we're still using the same drawing, and we're just using a little bit extra of our trigonometry theory. Right, the next one's nice because it actually asks you a double angle. It says evaluate 1 minus 2 alpha. Now remember, the drawing you've just done is not for 2 alpha. Okay, it certainly is not for 2 alpha. It is for alpha, the drawing that I had, and I think it's up there somewhere. Yes, there it is. It's alpha, you notice, not 2 alpha. So we have to find a way of changing our 2 alpha to alpha. Now, in the formula sheet, you've got all these formulas. But I'm a great believer in not relying on your formula sheet for something that you've done so many times that you know it off by heart. All it does is slow you down. So what I'll be doing at the last thing tonight is just learning a few of my formulas that will speed me up a bit. The ones I can't remember, those ones I can go and look at my formula sheet for. But it really does save some time if you don't have to look for everything on your formula sheet. Right, so over here we're going to go along and we're going to say that is 1 minus. And of course the formula sheet will show you that this is 2 sine alpha cos alpha, which of course then becomes 1 minus 2, and sine alpha we know, we worked it out in 9.1, it was 3/5. And then of course cos alpha, we would go to the drawing, cos is x value over r value, so it's 4 over 5. So it's 4 over 5. Right, so that's equal to 1 minus, now remember that becomes over 1, so I could say 2 times 3 is 6, and 6 times 4 is 24 over 25. And once again, this comes down to straightforward fractions. So we're going to put that over 25. Remember, that's 1 over 1, so it's 25 minus 24, which then gives me 1 over 25. So it's a nice question. First of all, it's tested. Do you understand the difference between special angle questions and Pythagoras questions? It's then tested, do you know your ratios? It's then looked at, do you know your reduction formula? And lastly, do you know your double angles? So it's a nice comprehensive question, and these are marks that most people can get if they just know how to approach the questions. Not hard to get those marks as such. Right, let's look at the second one that was sent in on Facebook, also on this document. Let's get it here. It's November 2010, paper 2, question 10.1. It says you may not use a calculator to answer the questions. Remember what I said to you. As soon as it says you may not use a calculator, we could be dealing with Pythagoras, or we could be dealing with special angles, and there is a third alternative. We could be dealing with our ratios or reduction formula. And in this case, we've actually got special angles and reduction formula. So again, a nice question sent in because we've had the Pythagoras version, now we're going across to the other end. So let's have a look how I know this. Right, as soon as I look there, remember I did a summary just now for you. 90 plus theta, 180 plus theta, and minus theta. These guys are special angles, and you would know them by now, I'm sure, but I'll recap them with you just so you can remember. Now remember what I said to you. As soon as we use a 90, the ratio will change. So this will change to cos theta. However, we would look at this original, and we'd say 90 plus is here, and in this quadrant, sine is positive. That's why it stays positive cos theta. All right, now we go over here. Plus 180 plus theta, that's a normal reduction. It's in the third quadrant. What do we know about cos in the third quadrant? Well, we know in the third quadrant only tan is positive, so it's going to become negative cos theta. Notice the use of brackets. It's always safer because the plus minus could get confused. You could forget, or I don't know, you could just mess it up basically. So rather don't, rather be careful. Now what I do when I see a negative angle, I always add on 360 degrees. Now if you take your calculators right now and you try this out, you'll see I'm not imagining this to you. Basically, if you take the sine of 30 and then you find the sine of 30 plus 360, which is 390, or you find the sine of 30 minus 360, which is minus 330, you will get the same answer for each one, which is 0,5. In other words, adding on a full rotation on your sine or your cos function will not change a thing. And in fact, that's also even true for tan, although its periodicity is 180. And later on, I'm sure we're going to have a question come up on graphs. So we'll look at that, and I'm sure we'll do some 3D and 2D and those kind of questions as well. But certainly, if you remember that if you add on 360 to a negative angle, it's really very easy. So what I would do in my mind is the following. Or not even in my mind, I could even just do it. I'd say this is the same as saying 360 minus theta, which means I'm dealing in this quadrant, which makes perfect sense. Minus theta would be that way, so it would fall in the fourth quadrant. And what do I know about sine in that quadrant? Well, it is negative. Again, notice the use of the brackets. This way it saves me making any careless errors. All right, now we go to the 180. Now this is special angles, and if you've been taught the triangle method, which probably a lot of you have been shown, the 180 would have to be reduced. If you've been shown, I think they call it the fan drawing, it's just like a circle, and that's the one I use, you don't even have to do that. So I will recap both of them for you quickly, and you can then work with the one that you're used to, and I will show you what to do in both cases. Right, so let's talk about the special angles. If you've been taught the triangles, you would know that this is 1 root 2, and this would be 45 degrees, 45 degrees. And then the other one you would know is this is 1, this is 2, and this is root 3, and this is 30 degrees, and this would be 60 degrees. Those are your special angle diagrams. Or if you've been taught the fan method, which is what I've always used, I don't call it the fan method, but I know that's what lots of teachers do call it. That's 0, that's 30, that's 45, that's 60, that's 90. Of course, this would be 180. I think I better just bring this up a bit. This would be 270, and this would be back at 360. Now, what we do to get this is we start over here and we go 4, 3, 2, 1, 0, and we go back 4, 3, 2, 1, 0. We then square root everything. So this one will become 2, 0. The next one, and I'm just going to use color so it becomes clearer what I'm doing, will become root 3 and 1. Notice I'm square rooting everything. And the next one will become root 2, root 2. And that's this 45 degree one. And then come back pens. Yeah, let's go back to the green again. This one over here is going to be root 3, 1. And then the last one that we've got over here is this one here, which is 90, which is going to be 0 and 2. Now, of course, if that's 2, 0, that's 0, 2. This one over here must be minus 2, 0. And this one must be 0, minus 2, just from the properties of a circle. So if you've been shown this way versus this way, it really doesn't matter. And of course, some people have even been shown how to use their calculators, and I know it said do not use your calculator, but I'm sure the teachers have shown you creative ways whereby a person can't really find out if you have or haven't used the calculator. Now, if you're using the triangles, you would have to think 180 minus 0 degrees or 180 plus 0 degrees, and it really doesn't matter which one you choose. If you're choosing 180 minus 0, you're talking in the second quadrant, sign is positive, the sign of 0 degrees, and this is where the triangles are not fun, and I suppose you would use your calculator if you've been taught the triangles. The sign of 0 would be the y value over the r. Remember, r is always 2, so it would be 0 over 2 or 0, and if it was negative, it would still be 0, so it really doesn't make a difference, it's 0. 135 degrees is in the second quadrant, so we're going to go 180 degrees minus 45. Which means I have tan in the second quadrant is negative tan 45 degrees. See, with this one, you can even go as far as using your trig graph. So you can say, look, I know a sine curve looks like this, and that would be at 180 degrees, so that's where it would be 0. So that might have been what you've been shown if you haven't been shown the fan method of doing it. Anyhow, it's fine. Whatever works for you at this stage is great, and I don't think you should worry about changing methods at this stage, so work with what you know. So, right, what do we have? We have cos theta. Here we have a negative times a negative, so overall it's a positive cos theta sine theta. And at the bottom here, I've got 0 minus minus becomes a plus tan 45 degrees. Right, now at this stage, we have to decide which one we're going to use. So if we're using 45 degrees, tan is the opposite over the adjacent. So you can see it'll be 1 over 1. Here, you would go to the 45 degree line and you say it's y over x. So it's root 2 over root 2, which also gives you 1. So either way, you're going to end up with the answer 1. So you've got cos theta plus cos theta sine theta all over. And of course, 0 doesn't count for anything. We're just going to have 1 at the bottom here. So in this case, now we can see all we can do to finish the question is take out cos theta as a common factor. And if we do that, we've got 1 plus sine theta. Now I can hear you all thinking, oh no, groan, what is she doing? Let's just show you. If I had this, would you have hesitated for 5 seconds to take out the x as a common factor? And you would answer, no, of course I'm not going to hesitate to take out that x. It's logical that that is a common factor, so I need to just take it out. So the same with this, the cos theta. We need to take it out in order to work with it, and that would be your finished question. Lovely, lovely question. I hope that's sort of given you a bit of a good idea. Now, I do have another one standing by, which I'm going to start, but we might have to go to ad break before I finish it. I don't know if we're due for our ad break yet. All right, so tell you what, let's wait for after the ad break, and then from there we will go back and look at this next question, which is a lovely question using a little bit of compound angles and a little bit of something else. Great, please phone in, remember, on 0861 058 262 so we can chat to you and help you, or to contact us on www.facebook.com/learn extra with an X, not with an EX, just an X, TRA. Right, good. We look forward to hearing from you after the break.